And now I'm taking discrete math now, and it's so cool. So that was about as far as I got until a couple weeks ago when I realized I had to choose a thesis topic, and I was like, what? What? Can't do that. That's ridiculous. How am I going to know? Oh, wait, I've been working on this for a while, and I really like working on it. Maybe I should turn this into a free fish. So my next question was, okay, so let's say these are blocks, and I want to, like, put them together. So if I had two that are smack dab next to each other, so if I have two cubes that are right next to each other, they share a face. So how many of those things are there? And so I worked on, well, first I had to figure out how to draw them first. So points, you can't put a point next to another point because you can't put it in another dimension. So, oh my god, draw a line next to another line. This would look like this. Etc., etc., etc. And so, how would that work, drawing it in these shapes? So, I'm going to do it with, I'll do it with cubes, and then no, 4 cubes. I'll do it with 4 cubes, and I'll do squares of squares. So I could do it as a 4 cube could be one of these moved, and then that moved again. So it could look like one of those. I don't know how well you can see it with the light, but this is these are 2 squares right next to each other. Or it would look like that, because it's one hypercube. It's just this. So then you put 2 of them next to each other, and you would get that. And these are the same thing, because they're both made using the same sort of algorithm that we're talking about. So they must be the same thing. But then how many? What would it have? How many faces and things? Because one of them's being shared. And then, so, because I'm in discrete math right now, I know ideas about inclusion, exclusion, and then we're doing graph theory right now. So this sounds a lot like graph theory. And so, like, you can add 2 graphs together. It's just like sticking them next to each other. Isn't any overlap because they're just added together. So what are 2 cubes sharing a face? How would you do that? Well, I have 2 cubes. And then, so now that face that they're sharing is double counted. So minus the face. Say I wanted 4 cubes all right next to each other, like that. Well, that would be, so I take 4 cubes, so I have 4 cubes. They're each sharing one face, 2 face, 3 face, 4 faces are being shared. So let's subtract 3 of them. Because, wait. Yeah, so each of these is being double counted, so subtract 4. So now I just have the 4 faces that I want, because we started out with 8, so we didn't want. But here, there's a line, there's an edge here that they're all sharing, and that was there 4 times when we started out. And then here, since all those faces share that same line too, we subtracted it 4 times. So let's add it back in. And so this is how many everything. Oh man, there's a glare. Know how to make the glare disappear. Well, this is 4 cubed minus 4 face plus 1 edge. Wait, 4 cubed minus 4 face plus 1 edge. So it's your inclusion-exclusion stuff. I'm just screensaver, that's weird. Alright, sorry about that. So that's that. Though, one way you can think about it is, this is 2 of these added together. So each of these we know is this. And then we know how to add 2 things together. So this is, this would be 2 of these. And then subtract that shared double face. So, but what's interesting, and what also makes quite a bit of sense, is that these 2 are equal to each other. So what's one of these? Where did we decide that was? Well, that's, so 2 times 2 cubes minus face. And then we subtract, what would this be? 2 squares minus the line that they share. So 2 faces minus edge. Put all that together, and you get, we have 4 cubes, so 1 times 2 times 2 cubes, so you have 4 cubes. So this is negative 2 faces, and then here we have negative 2 faces, so minus 4 faces, and then minus a line. There you go.